Section 4.7, one of the best sections, just so good. It sounds like I'm overcompensating with enthusiasm. It's fine. I'm just sort of joking around a little bit. 4.7 is about complex fractions, which makes it sound right. Literally, the word complex is in the name, so you would expect it to be really confusing and tough. Hopefully it's fine. Essentially what we're looking at are stacks of fractions, right? The sort of generic form for us here is going to be a fraction made of other fraction, a fraction of fractions. So that is sort of one big fraction where your numerator and your denominator are both themselves fractions. And the basic idea is just to sort of take this and just rewrite it as division, right? If you have one big fraction over another, right? If you have sort of one fraction over another, any of these fraction bars in some sense become division bars. And so what we're just going to look for is, this sort of long bar, the bar here that's a little bit longer than the others. It, in this case, right, sort of nicely divides this into sort of 2 on top and 2 in the bottom. We're just going to turn that into a division sign. And then from there, right, obviously we can still do our usual routine and then multiply by the reciprocal of the second one, right? So this sort of goes to division and then becomes multiplication. So this really is, like a lot of the things we do, it's kind of one new piece of information, right? We need to sort of make one change, one alteration, and then we're sort of back to something that we're familiar with. So let's see what this would look like with some actual numbers in here, right? It's always easier to actually sort of see these things in practice sometimes than to sort of see the generic version of it. So maybe I've got 15 over 16, and then that whole thing is getting divided by 25 over 24, right? A fraction over a fraction, right? This sort of big pancake stack. So the idea, right, step one is just to take this middle bar, right? This is sort of nicely balanced. Again, 2 numbers on top, 2 numbers on the bottom. We're just going to rewrite this. I sort of think of this as kind of going from like a vertical presentation to more of a horizontal presentation, right? This is sort of a stacked vertical division. This would be more of a long ways horizontal division. And it turns out really with fractions we kind of work more with the horizontal form because that's the form that we use to flip and multiply. So flip it, 24 on top, 25 on the bottom. And then from there I'm just using my usual strategy. Just break these numbers up, look for any kind of common terms to cancel. What do we got? 3 and 8, 16 would be 2 times 8. 25 would be double 5s. 15. 3 times 5. So we can do 5 and 5 come out of here. 8 and 8 come out of here. Let's rewrite what we've got left before this gets any more cluttered. Doesn't look like anything else is going to go, right? All these are actually sort of reduced down to their primes. So the last thing here to do is just multiply 9 over 10. And that's going to be our final answer, right? Easy peasy, no big deal. In theory, right, kind of as always, we could throw a couple variables in here if we want. Just to sort of change it up. We could do, 9x over 10y squared. Stack it up. Let's do, what should we do down here? How about 12 over, we already used 15. How about, well, maybe we'll go a little smaller. We counter program. Let's make this one actually 4, let's make this y cubed. Something like that. So, same start, 9x over 10y squared, divide by 12 over 4y cubed equals take it, flip and multiply. So when I do this again, you kind of break these numbers up however you want. Maybe we'll do the numbers sort of as a step 1, and then we'll clean up the variables as a step 2. I got 3 and 3, 2 and 5 here. 4 is going to be 2 and 2. 12 would maybe be 3 and 4. So if you do 3 cancels 3, 2 cancels 2. So what's this? 3x times 2y cubed. I'll go, right, y times y times y. I'll actually expand that out. All over, what do we have? 5, so y squared, y times y, times 4. And I'm actually going to take, right, 4 would break again. So that would be 2 times 2. So what's going to go? Well, we could do 1 for 1, y for y, y for y. We could do 2 for 2. We got one sort of pair of numbers still to work with. That leaves us with 3 times x times y over 5 times 2 over 10. And that's going to be our final form. So if we've got some variables in the mix, that's fine. Right, we'll just sort of expand them out, cancel them out, right, 1 for 1. Same as we've been doing in sort of all our other examples. One of the key things here is if you start to see some variables involved, don't necessarily let that psych you out, right? It's just another thing. They're not really going to interact with the numbers. They're only really going to interact with each other. So you can kind of just compartmentalize all these things apart, numbers to numbers, variables to variables. Don't try to do everything all at once and go from there. Both of these examples we did so far, right, there's, like I think I said at one point, right, are sort of nicely balanced. They have, right, kind of two numbers on top and then 2 on the bottom. The one thing here that you need to just watch a little bit is if you don't have things that are quite so nicely balanced. So, for example, if we had something like, I don't know, 3/8, and then the whole thing is like divide by 12, but like just 12, right? This is just sort of 12 by itself. What you need to do is you need to make sure that as you rewrite this, we're going to sort of follow the same strategy. But the idea is going to be, identify where the sort of main division is happening. The longest fraction bar is going to be sort of what we turn into a division sign. And my kind of preference here is to just sort of rewrite the whole thing. So this is 3/8 on top, and it's over whole number 12. What I would do is I would actually just rewrite that. Rather than 12 the whole number, I would just turn it into a fraction, 12 over 1. So then you can still sort of in one step get that nice sort of 2 over 2 balance going, and then go from there, right? So then this will be 3/8 divide by 12 over 1, which then becomes for us, right, 3/8 times 1 over 12. In this case, right, kind of one of our 4 positions is just going to be a 1. It's kind of a trivial number. These numbers weren't really so big to begin with. We're going to do 3 cancels 3. So this ends up as essentially 1 over 8 times 4. So this becomes 1 over 32. As a general rule, right, if you're dividing by a whole number, you're going to sort of end up with a smaller result. So we go from 3/8 on top divided by 12 gets us down to 1 over 32. You could imagine maybe if we sort of flip these roles around, we put a bigger number on top. If we put a whole number on top, we'll have a similar strategy. It's just going to look a little bit different. Let's throw 18 up top. Let's divide this by 12/5. So same idea, just now, right, our sort of long division bar is between the 18 and the 12. So the pitfall here would be to sort of accidentally call this sort of 18/12 divide by like 5 over 1. That's not really where the sort of main division bar lies. This is really going to be an 18 over 1 that's then divided by the 12/5, right? So we just have to kind of watch for that sort of widest division bar is really going to tell us how this sort of splits overall. Once we've got that, right, 18 over 1, divide, 12/5, flip it, multiply, right, the usual routine. Here, I'm hoping probably very comfortable with these steps at this point. 6's will go out, 3 times 6, 2 times 6, 6 and 6, so 3 times 5, all over 2. So this will be 15 halves. And that's the basics of it. So that's us getting started. So complex fractions give us these stacks, right? Stacks of fractions, fractions made of other fractions. You could imagine, stacking sort of a stack over a stack. I mean, obviously this in theory you could sort of scale up and up and up as much as you wanted to. It just would take a little bit longer to sort of piece out and sort of peel apart where your numbers are all going to end up. In theory, I mean, if you had one of these stacks, I mean, it becomes, right, a sort of multiplication like this. If you had one of these stacks over another, right, with sort of 8 total values, there would be kind of a way to sort of peel it apart, flipping these things with division. Some of these, lots of different divisions. So some of these things are going to flip, and then they're going to flip again because they're actually, dividing, and then they're part of a denominator, so they get flipped again. It's possible to sort of take those things all apart in that way. Obviously, the more numbers you have, the longer it takes. But if you're sitting around bored and you're just sort of thinking to yourself, man, I really would love to just like do some number stuff. I would just like to see some numbers just go all over the place. Try a bigger stack. Otherwise, for everybody else, which is probably just everybody, this will probably do for now.